Hey guys, and welcome back to my channel. I just wanted to create a follow-up video for my Micsig STO1004 oscilloscope review. You guys have left a bunch of comments both here and on the EEV blog, and I'm really grateful for that. But interestingly, both the Micsig company and the US distributor Selig have responded as well, which is great to see. And what's more awesome is that Micsig left a comment saying that the issue where the oscilloscope app crashes with a mouse dongle plugged in has been fixed. I haven't performed the software update yet, and I wanted to do it on camera to see what that looks like. The problem is this wireless dongle right here. I will plug it into the scope and let's see what happens. Ready? Oh, in this case the app kind of half crashed. This is actually different. It's sitting in wait position. The mouse is actually connected, but the oscilloscope app is frozen. And now it crashed. So now if we go back to the app, now it's working again. So this is the behavior before any update. Now let's try to perform an update. So first I'll go to the home screen, then pull down on the top menu and connect to Wi-Fi. Hopefully my hotspot is working. It is. And we're connected to Wi-Fi. Now let's try to do an update. We'll click on System Upgrade and let's see what happens. It says no new version. So I was kind of puzzled by this for a little while because System Upgrade said no new version. And then I realized that there's kind of an app store here, which is this right here, the app market, right? And here you can see that an update is available for the Smart Oscilloscope app. So let's try an update. And now the download seems frozen at 20.22%. I'm on a very fast 5G network on my phone, and as you can see, it's not doing much. Well, I guess I'll try it again. Quit this, go back to the app market. Let's try this again. It's not working now. Let me restart the scope and see what happens. Okay, I've just restarted, and I will quit every single app just to be sure. And then try the app market again. Then I'll give it a bit of time. Now let's try the update. Okay, so it's doing better this time. Okay, the update has downloaded and now it's asking me if I want to install it. Now it's done. Let's try to open it. Everything looks good. And now for the main test, I have the dongle just slightly inserted into the side of the oscilloscope, and as you can see the mouse is not working, so I'll plug it in fully. Hooray, it's fixed. No problems. So guys, this is really great. Micsig watched my video, they saw the issue, they fixed it, and informed me that the update can be downloaded. Personally, I'm very impressed with this fast turnaround time for this particular issue. Someone in the comments on the EEV blog forum pointed out that it didn't show the timebase menu, so here it is. You can just click on this and all the timebase options are displayed, so you can set whatever you want. And it'll work just like that. Or of course you can use these buttons to increase or decrease the timebase. Another person asked me what it was like to scroll around a very large waveform. And so here's 70 megasamples being saved, right? This waveform right here. If I zoom in, you can see it's still decoding the data. It's still triggering correctly because for the trigger I have it set to your trigger on 0A hex word. So I'll go back to 70 megapoints, and if I single shot this, right, and let's say I use a zoom function to zoom into the waveform, here I can try scrolling around this waveform to see what happens. So with 70 megapoints, it's actually fairly unresponsive. And just now it for some reason zoomed in. Not quite sure why. And so see, you have to kind of let it go in order for it to update, which is obviously not ideal. I definitely feel like the algorithm that they're using for this can be improved substantially. I suspect what they might be doing is that every time that you scroll around, the waveform update function actually reloads the entire waveform and then finds the positions where the user's viewports would start and end and then display it, which is very slow. So I think with every update, it's just iterating through the entire waveform. And this obviously doesn't have to be that way because we're stopped, right? So this waveform is not going to change. So there's no need to update the entire waveform every time you scroll around. All you have to do is buffer a little window around the section of interest, and then load a very small amount of data next to each boundary. And now let's try this on a smaller number of samples. So now we're at 700k points. Why not? Let's try this. So I'll stop it, I'll go to zoom, and let's see what that's like. Okay, much better, right? So with 700k points, the scrolling speed is much faster, and of course I can do this as well to scroll around. I can move the waveform vertically very easily, and generally speaking, it's not very laggy. If you look at the serial decode, it's having no trouble catching up, right? So this is very workable. But again, I think it could be faster. If they used a faster algorithm for reading the waveform, for what's being displayed as part of the zoom function, this could be a much faster experience. Here's another problem. I can use this joystick right here to scroll around the waveform like this, right? So if I zoom out a little bit, and then I use this function, this is pretty convenient, right? Because I can kind of scroll around the waveform and maybe read longer bits of text this way, right? And now it's 7 megapoints of memory. It's still fairly usable. It's quite responsive, almost identical to the 700 kilopoints of memory. But see, now I'm accidentally somehow zooming into the time base, which is not good. So I think I actually figured it out. And here's the problem. When I scroll around the waveform, this is more or less a continuous motion, right? See, it just did it again. I'm not lifting my finger off the screen. But once in a while, the time base gets reduced, right? Look, it did it again. And that's because it's detecting my swipe as a double click. Because if I double click on the waveform, that's the same as zooming into the waveform, right? Reducing the time base. So if I'm just, let's say right here, and I double click somewhere, see, even the double clicking is not consistent. See, it doesn't detect it. Now it detects it. But I think that's what's happening. So I'm not sure how they have this programmed, but it sounds like the function that's detecting inputs from the screen might be interrupted by another function such as the waveform update or some kind of hardware interrupt. But of course, you can use the joystick to go left and right, and you still have acceptable performance at 7 million points. Because I can just do this continuously. But now let's see what happens at 28 million points, right? So we go to zoom, and we zoom in until we can see the decoding, and now I'll try to pan around. And so that still actually works, which is very impressive. Honestly, for 28 million points, even using their very inefficient algorithm that they're using, this is really good. This performance is still excellent. Completely usable and functional. So even as I expand this window, I can pan around the entire waveform and the performance is good. And now we have 70 million points, right? So if I zoom into this, and I kind of zoom in like that until we get a serial decode, and I try to pan around, look how slow it is. So I'm not 100% sure where this inefficiency is coming from, because at 28 million points it was quite fast actually, but at 70 it's very slow. And now you can't really use this control anymore. You can still use this control to select where your zoom window is, but as you move the zoom window around, you don't get an update until you've stopped moving the window. So this isn't very useful. So, 70 million points is definitely pushing it, but I feel like they could certainly optimize this if they wanted to. And so to summarize, as long as you're using 28 million points or fewer, it's actually very responsive to scroll around the waveform. And so here I've disabled the your trigger, and you can see I'm capturing 28 million points, and I'm zooming into that 28 million points as it's being captured. It's being decoded, and look at this, I can still scroll around the window just fine, and I get a decode just fine. And if I stop it, and I scroll around, then I don't even lose the decode in between scrolling. I can still see it, and I can use this function to scroll around the entire waveform. However, I think it might be possible for Micsig to actually modify their algorithm to make it more efficient. And now check this out. This is Micsig's Oscilloscope app. My phone here is pretty new. It's the Samsung Galaxy S22 and it's got a very, very long screen, and I can kind of see that the image that it's sending is being stretched a little bit. But this is basically, from what I can tell, probably just H.264 video that's being captured directly from the scope and sent over the network. And because of the fact that the scope's intranet is being tethered from the hotspot on my phone, I can just get the IP address that the scope is connected to, enter this IP address here, which is obviously a local IP address, and the app simply works. To get your IP address from the oscilloscope, you would go to the Wi-Fi connection that you're currently connected to, scroll down, go to Advanced, and then you can see the IP address right there. So this is the IP address that you would enter into the oscilloscope app. I can single shot, I can use all the controls. So you basically get the absolutely regular oscilloscope app that you have on your actual oscilloscope, but on your phone. And this is fantastic. Let's see if I can swipe from the top. Look, I can, and I get a menu, right? I can probably do the same thing from the bottom, or not. Okay, there we go. You have a menu here, and I can adjust my trigger levels and set the oscilloscope mode. And when I run the scope, obviously it works. And of course I can change the time base. And here we go. Let's try to enable the UART trigger. So if I go to trigger and I scroll to UART, there we go. I'm on data equals 0A, and that's good to go. This is being triggered. And so now if I get that menu again and I go serials, I open the serials window, you can see that it's capturing data just fine. So if I stop it, I can scroll around the window and take a look at the data. You can see some compression artifacts sometimes. Let me zoom into that. So you can kind of see that compared to the actual oscilloscope, there are some artifacts present on the video feed from the scope. Very truthfully, if I was trying to make this oscilloscope application for the phone, and I was trying to do it as easily as possible, this is exactly what I would do. I would just send a direct video feed from the scope. This means I don't have to replicate any of the user interface elements, and then I just have to implement a very simple touchscreen control on top of that, which maps to the original buttons. This is very easy. In some sense, it's a very simplistic and cheap attempt to make this work, but because it's simple, it works very well. And of course, it also means that you can go to the home screen, for example, right? And you can keep using your tablet normally and do whatever you need to do as though you're operating the tablet screen directly. Does that make sense? You can switch between apps and do whatever you want. Generally, it's fairly responsive. If I keep popping up the time-based menu, you can see that there's almost no latency. There's maybe something like 50 milliseconds of latency here. It's very short. A couple of people wanted to know what these joysticks feel like. And honestly, they feel pretty good. You can use them by pushing from the side, which is very easy, but they also have textured tops, which are very grippy, so it's easy to just push them this way as well. You can use your thumb if you want, and I would argue that's a little bit easier, or you can use your index finger, or whatever you prefer. One thing that I personally like about them is the fact that they're very easy to push. In the sense that when you push them down as a button, there's no chance that you would tilt them up or down or left or right by accident. Because it takes a fair amount of force to tilt them in any of the 4 basic axial directions. And so pushing them down as buttons is very easy. So for what it's worth, in my personal opinion, I think they're very well made.